So delta S 0.01. So you evaluate the function at 1001, you evaluate the function at 10, find the difference, divide the change by the change in the underlying price. That's kind of the rate of change. So derivative says, that thing depends upon exactly what delta S0 is. Keep doing that with smaller and smaller changes. That rate of change is going to kind of be constant. Just to give you an idea, suppose we have a function x squared, okay? And I wanted to calculate derivative of that, which unite with f prime x, which is df of x dx. This is limit as delta x goes to 0, x plus delta x. Let's take this down. What is f x plus delta x? That's x plus delta x squared, which is equal to x squared plus delta x squared plus 2x times delta x. Okay? So what is f of x? X squared. So if I calculate the difference, I'm just going to call this delta f, change in f, x squared plus you'll see this cancel out. So delta f over delta x. All right. I basically divided that by delta x. Remember, delta x is never exactly 0. So we can actually make that division. What I want to know is limit of as delta x goes to 0. If you make delta x exactly 0, this thing is actually 2x. So if I wanted to remember the function, it's not what I wanted to do. Well, let's go draw it. For the positive parts, it's going to be something like that. Suppose this is me. If I wanted to know the rate of change of the function at that point, all it comes out is 2 times the value of x, so it's 2. If I'm evaluating it at 2, that's 4. And it also happens to be 4 in this case. Okay? Or f of 3 is 9. As you can see, as I increase x, that f prime also goes up. If you look at that picture, the function gets steeper and steeper. What do you mean by slope or not? Anytime you have a nonlinear function, you cannot talk about the genetic slope, the rate of change of it. You have to talk about specific point. That's what a derivative is. It's just a fancy name for, let me see where it is. Then you make small changes, the argument or the input. What is the rate of change of the? That's all that derivative means. All calculus is all about. Of course, you have nice little rules. But if you didn't know anything, sometimes the function that you calculate doesn't have formula that you can write. For example, we're gonna start talking about American options. And we're gonna talk about options that actually own stocks that actually pay a dividend. Then we have no closed form formula like the Black-Scholes. We implicitly know it is a solution to a partial differential equation. VBA to write code to solve that partial differential equation. Partial differential equation is something that describes the evolution of a function over time and over values of an input. For example, this function, as time to maturity or expression gets smaller and smaller, the slope changes, or at higher values of x, slope changes. You don't need to know about all that fancy differential equation stuff. We have a nice little way of constructing framework where solution of that differential equation is just in our hands. The trouble is, I cannot write a formula. So even if I knew all the rules of calculus, okay, in terms of differentiating a given function, I have nothing to do that's symbolic. So I'm going to have to calculate that numerically. So what we're going to do in this class, we're going to talk about numerical differentiation. I'm going to kind of keep things simple. It basically says if you have a function, let's say y equals f of x, okay? Choose the delta x small enough. And we typically choose delta x, if I'm doing this just for calculus purposes, absolute value of x times 10 to the negative 8, something like that. If absolute value greater than 1, otherwise just 10 to the negative 8. Okay? It's something small. There is no hard and fast rule about how small it should be. Ideally, we wouldn't want to make 10 to the negative 50, but we have issues with computation. In computing, there is a specific number. Each computer has a specific number called machine epsilon. In scientific terminology, epsilon is typically reserved quantity that are very small. As long as you know what we're talking about. And let's call this epsilon bar, right? Epsilon bar is such a number that for any x is not x, absolute value of epsilon less than epsilon bar, computer evaluation of 1 plus epsilon is equal to 1. Let's say epsilon, let's get epsilon and 10 to the negative. If you added any number on the computers that is smaller than 10 to the negative 15, to 1, computer gives you exactly 1. Okay? Why? Because, we can represent numbers only in discrete way. They're called floating numbers. In fact, there are finitely many of them. It's not even countably infinite. You can represent in double precision any number from about 10 to the negative 10 to the 308 to about positive 10 to the 308, which is the entire number of molecules in the entire universe. It's about 10 to the 8. But you can only represent a finite many. Even between 0 and 1, there are finite many floating. Because you can't represent everything. Normally, between 0 and 1, there are finitely many rational numbers, but there are infinitely many, in fact, uncountably many irrational numbers. That's why we can't pick that small kind of a rule of thumb is use delta x equals absolute value of x times square root of mission x. So if you don't have the ability to symbolically calculate what the derivative would look like, for example, look at that thing, okay? Ignore that thing for now. For a stock that does not pay dividends, call option delta is N of D1, basically. Remember, we were calculating that N of D1?